Vectors. So I think you heard about the vectors previously. It's not very difficult to you, and it is not necessary to you to explain more also. But what is meant by vector? Do you know? Vectors, scalars, difference क्या है? What is the difference between the vectors and scalars?
Vector have direction and scalar doesn't have direction.
Hmm? Vector.
Vectors have direction.
Scalar don't have the direction. Only
Direction.
magnitude. Only magnitude is there. Okay, very good. So so is it visible to you? Presentation.
Yes, sir.
Yes, sir.
So if you take a point here like this, so what is a possible location of the point which is 10 centimeters away from this point P, which is present on the circular region. A circular region में 10 centimeters distance में होता है. So that is normally a path, means A is a point moving here from the means one place to other place 10 centimeter distance में इधर P point से किधर भी दे ले लो, it is 10 centimeter distance. Wherever the point you are taking, the distance is 10 centimeters. So it is fixed. It is not changing that. So distance is equals to 10 centimeters here, and it is having a, it is called, suppose if you are taking directions north upwards, east right side, and west left side, and south downwards will be represented. Suppose if I am asking that any point north east towards the east means the point A will be represented from the point A. So direction we are showing here towards the east. I am saying towards the east. So that is called displacement, which is called as a vector. The upper one, first one is whenever you are taken into consider, it is scalar, and second one whatever you are taking, it is a vector. Vector will have the magnitude, means distance, and as well as some direction will be shown to you. So when you it is shown to your direction and as well as a displacement, normally displacement you can call, or you can call the distance here, and magnitude we call it as a magnitude. So that is called as a vector. So in this situation it is a vector. So three-dimensional 3D means three-dimensional space if you are taking into consider, this is called a line. It is directed line. The line whatever you are showing, directed line. So because it is showing the one direction towards the one way, so that's why it is called as a directed line. The basic things we are learning here in the vectors now. Okay, so it is a directed line, and if you mark the 2 points, it becomes a line segment. Line is going to have a no length. A line segment whenever you are taking, direction के साथ है a directed line segment. It is a directed line segment. A B with an arrow mark ऊपर, just like a ray if you are showing. It is going to have a starting point A, ending point B, and this is usually denoted by the small a bar, a vector. So this is vector because it is having a direction and as well as magnitude. The first one is line. So it is not having a magnitude. So what is directed line is different from the directed line segment. A is a point if you are taking, and B is that point A is called as an initial point, and the point B is called as a terminal point, ending point. That is. So point B, whenever you are taking into consider, it is called as a terminal point. So A is called initial point and B is called a terminal point. So directed line segment AB bar is in a simple way can be written as A bar. And magnitude will be written as magnitude of the any vector is written between the two lines, just like a modulus. In a short form, you can write it as a simply A. So directed line segment BA ऊपर से नीचे तक means reverse में, तो उसका negative vector, it is called as a negative vector. So different types of the vectors also will be there. So that also we are going to learn types of the vectors में zero vector, null vector, co-initial vector, like that different vectors will be there. Here it is the opposite direction में आ रहा है, so that's why it is called a negative vector. So a magnitude will be same for the BA and AB, because A to B distance and B to A distance you take into consider, same distance you are going to have. So that's why their magnitude is same. So now you take the any three-dimensional space into consider and a point P in the three-dimensional space as a x comma y comma z. A point is taken as a x comma y comma z and O to P join karo, then that is called as a position vector of the point P. It is called as a position vector of a point P with respect to the origin. So it is represented by r bar. Usually the distance between the 2 points formula, you know that will be applied here because magnitude whenever you are taking. So under root of x square x minus 0 whole square plus y minus 0 whole square z minus 0 whole square you are going to get. That is x square plus y square plus z square. So magnitude of vector r is written as under root of x square plus y square plus r square. It is in a simple way will be written as small r in a simple way. Okay, समझ में आया this part? Now if your this is origin, this point is origin, and if any line makes an angle of alpha, beta, gamma, see here angle how it is making that line, whatever the line we are taking, directed line, it is making an angle of red color angle is alpha with the x-axis and blue color angle is beta y-axis and z green color angle is gamma. So now here in this figure I think so you will come to know that how the angle is making in the three-dimensional space. From the corner of your room you take the one line, a corner से एक line ले लो, and these are called the direction cosines of the vector. Direction cosines means if cos alpha, cos beta, cos gamma are called direction cosines of the vector. So we take the direction cosines usually will be represented as a LMN. LMN. L is equals to cos alpha. So the M is equals to cos beta, M is equals to cos gamma. So if PA is perpendicular to the x-axis, if it is perpendicular to the x-axis, that OA is equals to x. If it is perpendicular to the x-axis, then OA is equals to x hoga. If it is perpendicular to the y-axis, OB is equals to y hoga. And if it is perpendicular to the z-axis, OC is equals to z hoga. If it is perpendicular to that P to C perpendicular to the z-axis, if you are taking, then OC is equals to z. So the distances. So that here to O to A distance is OA, X, Y, Z, that points. See here in this figure, I think very clearly you will come to know that. That's why vectors in 3D you have to learn like this, so that it is an easy task to you. And when you take that triangular form, cos alpha is equals to x by r, we are going to get. The triangular part is taken from that, and it is cos alpha is equals to right angle triangle OAP. Alpha angle is taken into consider. Okay, so that is OA by OP. X is equals to LR. L is written as direction cosine of the vector position vector OP. So in the same way, y is equals to MR you are going to get. Y is equals to MR. Z is equals to NR you are going to get. It's very simple here. The triangles are taken. That from that the part triangle is taken up and it is applied cos beta. So cos beta is equals to OB by OB is equals to Y, because it is perpendicular. It is already mentioned, and magnitude of r is nothing but r, simply r it is written. So y is equals to mr you are going to get, and in the same way, see here that triangle is separately taken and it is shown to you there. Perpendicular, here it is given to you, they are perpendicular, it is not showing to you perpendicular there. So the figure, if you are taking into consider, easily you can understand. So these are direction here whenever you are taking the ratio of x by x to r, y to r, z to r. Direction ratios we call them. Direction cosines are represented by LMN. LR, MR, NR are called direction ratios of the vector R. Vector R is nothing but here position vector of a point P with respect to the origin. So here L, M, N are direction cosines, LR, MR, NR are direction ratios, and we direction ratios को small a, small b, small c से represent करते हैं. We represent them with the small a, small b, small c. So L square plus n square plus n square is equal to cos square alpha plus cos square beta plus cos square gamma, which is equals to 1 you are going to get when you simplify it. X square by p square plus y square by p square plus z square by p square. P is nothing but the distance here, actually r here. So that is under root of, here r square should be taken, not p. P is mentioned here, it is wrong here. So r should be taken into consideration. So L square plus m square plus n square value equal to 1, and a square plus b square plus c square value is equals to r square. P here ऊपर P लिखा है ना, वो P का प्लेस में R आना है ना. Okay, a square plus b square plus c square is equals to r square. Sum of the direction cosines will be equals to 1. Sum of the direction ratios will be equals to the square of the radius. So now let us see the types of the radius. A is a one point and B is another point if you are taking into consider. If these two initial and terminal points coincide, दोनों different points है, but ये दोनों coincide हो गया है, तो means there is no distance is there, then that type of the vector is called as a zero vector. It is very clear to you, I think so. Through this easily you can understand. That's why I am explaining to you like this. Zero vector, and the magnitude of the zero vector is, zero vector को O represent करना है, actually O vector O represent करना है, and the magnitude of the zero vector will be equals to 0. This is zero vector, and the vector whose unit is equals to, whose magnitude is equals to 1 is called as a unit vector. The first one is zero vector or null vector. Okay, these two vectors started from same initial point, co-initial vectors. We call them as a co-initial vectors. Two vectors are started from the single same point, so that's why we call them as a co-initial vectors. Okay, so if two vectors are, two or three vectors are parallel to the same vector, say go L line is taken, for this OP, MN, EF in different directions में दिखा रहा है, but they are parallel होता है तो collinear vectors. Please note this point. Mostly collinear means, usually you may think that collinear points में एक ही line में होता है तो collinear, but here parallel lines, parallel vectors को collinear vectors बोलते हैं. The easy terminology is parallel. You can consider parallel. So they are called as a collinear vectors. Parallel होता है तो collinear vectors. कोई initial is nothing but एक जगह से start होता है. If they started from the same point, then they are called collinear. देखो here AB, OP, EF are same direction they are having. So if their direction is same and magnitude is same, then the two vectors are called as a equal vectors. The two vectors are called as a equal vectors. समझ में आ रहा है अनुराग? सिंपल है, इसमें कुछ नहीं है. So initial point is same, different terminal points and opposite direction में है. One vector is in opposite direction. This is called negative vector. Normally to the given vector, magnitude is same, but direction is different. So negative vectors. About the negative vectors, starting में भी एक बार मैंने बोला है. The two vectors are called, and representation कैसे है? इधर PO is equal to magnitude of PO equal to magnitude of AD, but direction is different, opposite direction में है. So PO can be written as minus AB. AB ऊपर की तरफ है, BA नीचे की तरफ है, plus BA you can write, and minus AB you can write, that PO vector. So equal vectors समझ में आया ना, equal vectors and negative vectors. And collinear vectors बोले तो collinear means parallel हो रहा है. Okay, so types of the vectors once again here, see here, the two vectors whenever you are taking into consider, AB is vector and another one is AB, same vector, another vector, here it is separated. You see this one so that you will be able to understand very clearly. These are all free vectors. Actually this is not there in your textbook में maybe नहीं है. So that type of the vector, same vector is, but place is different. AB is shown to you in different places में दिखा दिया, so that is different. Okay, so base till now you can solve the exercise 1, first exercise problems. Now addition of the vectors is there. Addition of the vectors concept and scalar multiplication of the vectors and properties of the addition of the vectors, let us learn. So that two exercises at a stretch you can do it. So if you take the vector A is from the point, initial point A to B, and B vector is B to C. If a girl is moving from A to B, or a boy, you consider a boy is moving from A to B, then after B to C. So the shortest distance is A to C usually. So A to C is short distance. So this is called a triangular law. We call it as a triangular law of the additions. Okay, so A plus B, that AC vector can be written as sum of the vector A and sum of the vector B. So do remember that here A is vector from A to B, B is a vector from B to C. The union means addition of these two vectors will be written as A bar plus B bar. So AB bar plus BC bar is equal to AC bar. Simple here, nothing complicated in this addition of the vectors. Just you are going to have the next two exercises, dot product and cross product. यही है, रिवर्स में ले लिया है सपोज. CA नेगेटिव होता है, A बार माइनस B बार B. Okay, wait for a bit. Is the presentation visible?